Hi, sorry about that. I accidentally closed my app that I was going to start the lesson on. So, welcome to the latest episode of MathMeowTics. In this episode, we're going to talk about multiplying and factoring. And we're going to specifically be multiplying and factoring polynomials. One of the things that I wanted to add on here, that they have the vocabulary here: argument, set of statements put forth to show true, falsehood of mathematical claim, and justifying. I wanted to add one vocabulary to this, and the vocabulary that I wanted to add is what's called a GCD, or in mathematical terms, that is the greatest common factor. So GCD, or greatest common factor. And what the GCD means is, let's say, for example, that we have a number such as, let's say, we want to look, or we have two numbers. We have 12 and we have 16. All right. Well, the factors of 12 and 16, let's see, the factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 16 are 1, 2, and 4, and 8, and 16. All right. We want to look at the common factors that are between the both. So the common factors that are in between both of them are, of course, are going to be 1 and 1. And we see 2 and 2. And we see 4 and 4. All right. Now, the greatest common factor, so that's the biggest factor that we're looking at. Yes, we have 1 and we have 2, but we also have 4. The greatest means that's going to be the biggest number that we have that's going to be in common between the two numbers. All right, in this case, the greatest common factor, the GCD, would be 4. All right, so I just wanted to do a quick review on the greatest common factor before we get into that, into multiplying a monomial by a polynomial, because it's going to come into play later on. All right, so if we look here, multiplying a monomial by a polynomial, you can multiply the monomial by a polynomial using the distributive property. For example, we want to consider the product, and product by meaning that I'm multiplying. So that I have this number here, or this term, 2x, and it's the coefficient of everything that's inside the parentheses. Well, we know that we have to distribute that. That's the rules that we have in terms of a coefficient with parentheses. So when I distribute that, I have to distribute that 2x to both terms inside my parentheses. And we also talked about that in the last episodes in adding and subtracting polynomials. So that gives us 2x times 3x and 2x times 1. So our final result is going to be 6x squared plus 2x, because if we remember back to our rules of exponents, when we multiply same base, all right, we have to add the exponents. So our exponents there for those x's are going to be 1. So I need to add 1 and 1. I need to add my exponents, which will give me 2. And again, I don't have any I don't have another x value term in here inside the parentheses. I just have 1. But we know the rules that when we're multiplying 1 by anything, we keep it. Now, you can also make sense of the model by looking at a table here. All right, I have I've created two charts. So I have a rectangle. So I have three x's. I have 3 x's inside my parentheses, and I also have 1. So x plus what x, that will give me 3x, plus 1, that will give me the 3x plus 1. Then I have my 2 x's here. All right, that's outside the parentheses. Now remember, I could take that further. If I had 3x plus 1, then I would have one more column here, and I'd have plus 1. But currently on this problem, I don't. All right, well, now I'm going to do the area for each square. So this square here is x times x will give me x squared. Again, x times x will give me x squared. And again, x times x will give me x squared. And then x times 1 will give me x for that column there. And I'm going to repeat the process for the second row. Now, if I add these rows here together, that's going to give me x plus x, which gives me 2x. Then if I'm going to add these 3 here, so I have 1, 2, 3. I have 3x squares, and then I have wrong directions. I have 3x's plus 1. Now, again, in terms of talking about rectangle, we're going to do rectangle's area is equal to base times height. So that's going to be 2x times 3x plus 1. All right, and again, we can look at it and reason it through that and talking about that problem that way. All right, so now here we're going to have our first polynomial, and it's a polynomial only to a degree of 1. But if we think about it, it's going to become a polynomial of a degree 2 when we factor it, when we put it in a simpler form. And we need to remember that it's important that we distribute that negative x to all the terms inside our parentheses. So I'm going to say negative x times 9x plus negative x times 7. Right? So that's going to give me negative x times, so remember these are 2, 1, and we're multiplying, so that's going to give me negative 9. I need to keep my negative here because it's not inside the parentheses, so my negative is not going to go away, it's going to stay, because a negative times a positive is a negative, so, and it's essentially a 1 x times 9x, so that'll give me 9x, and then I have to add my exponent, so my exponent's going to be 2. Now again, I have plus a negative here, so this my answer, if I have a negative times a positive, that's going to give me a negative in my answer. So that's going to be, again, negative 1x times 7, which is going to give me negative 7. So my answer for the expression is going to be negative 9x squared minus 7x. And let's see which answer that's going to be correct. It won't be that one because that negative 9, it needs to be negative. And it won't be this one here because, again, we didn't distribute our negative sign properly. And it can't be this one because I don't have, also on C, I don't have the x with 7. So our only possible answer choice, and of course we can also match it to our answer, is D. So D is our answer choice. All right, and now on problem number 2, we're going to talk about GCD, or greatest common factor. And let me do another video on that one so that I'll do problem 2 and 3 on that one. See you then.